looking at inverse matrices. Okay, so what's important to understand is that when we have a matrix, if we want to get it the same matrix, we have to times it by like number 1, right? 3 times 1, we get 3, 4 times 1 is number 3. Now to do that, we have to get this thing called an identity matrix. This is known as the identity matrix, these ones here. This is a 2 by 2, because if we have a 2 by 2 matrix, we have to times it by 2 by 2 identity matrix, which you can see it's an identity matrix because there's number 1s over here on the diagonal and everywhere else 0. This is a 3 by 3 identity matrix. They have to be squares. They can't be anything but square matrices. Okay? So if I times that identity with A, that is the same as timesing the A with the identity, which is just going to give us a matrix. Now, this is very important for the 12B exercise, right? Very, very important. Now, why do we need this? Because when we're going to solve matrices, so if I have this matrix over here and an X matrix equals something, and I'm trying to solve for X, the only way I can get rid of this A is by doing the inverse. Because when I times the inverse and itself, I'm going to get number 1, the identity matrix. And of course, the only way, if I times it here at the front of the A, then I have to times it at the front here. Okay? And that's how I'll get rid of it. It's just like when we've got 3x equals 2, I say solve for x, you go x equals 2 divided by 3 times here, divide over here. Well, we can't do that with matrices. We have to do the inverse of it, just like sine, cos, or tan. Make sense to you?
Yeah.
Okay, so I'm just going to clear all this. All right. If we work out this thing called a determinant, and I'll show you how to work that out, and it equals 0, then we are not able to find the inverse of the matrix. Okay, and I'll explain later why that is. Okay, but that's very important. Okay, let's continue. Okay, how do we find the determinant of a matrix? Now, you would have done this, but if we've got this matrix over here, and we always give the matrix a letter, this one's called A, okay, and it's capitals, and inside, of course, there's always the little, they're called A11, A12, even though I've called them A, B, C in here, that doesn't matter, it's because to use the rule. So to find the determinant of A, and you must write it like that, don't worry about this one, it equals A times the D, so we get these two numbers, we times them together, and then we get the other two numbers, B and C, we times them together and we subtract them. That's very, very important. Because then we're going to get this answer, and to find the inverse of it, we're going to do 1 divided by that determinant. Now, what happens to the matrix? Okay, let me just erase this. What happens to the matrix? The matrix, these two swap position. So you can see the D became the A, and the A went to the D position. The other two, they just change signs. So if they're positive, they go to negative. If they're negative, they become positive. So they change sign. That's also very, very important. Remember, this only can happen, you can only work out the inverse if the determinant does not equal 0. Okay? All right, clear that one. Question 1.
Wait, why did C and D become negative?
You change the sign.
C and D
Opposite, yeah, just for B and D, you just change the sign. Okay,
but not
very
A
important.
and D.
Not A and D, they change position. So A and D change position, B and C change sign. Yep. So AD change position, B, C change sign. So positive goes to negative, negative goes to positive. Okay, very, very important. Okay, let's do one. Question 1, for the matrix, show that the inverse, sorry, not the inverse, the identity times A equals A times I, which equals A. Okay, let's do the first one, I, A. Okay, because it's a 2 by 2, we're just going to use a 2 by 2 identity. There it is there. Times A, 1, 2, 3, 4. Okay, I'm going to do a theory with you, but of course you can just put those into your calculator with press the times in between and get your answer, which will be 1, 2, 3, 4. But I'm going to show you the theory way. Now remember, when we multiply, we do the row times the column. 1 times 1, 1. Plus 0 times 3, 0. Now I'm going to do the next column. 1 times 2, 2. Plus 0 times 4, 0. Now I'm going to do the next row. So that means I start on the next row here. 0 times 1, 0. 1 times 3, 3. And the lucky last, the last column here, 0 times 2, 0. 1 times 4, 4. And if you work all that out, you can get 1, 2, 3, 4, which equals the A. See, it's exactly like timesing by number 1, isn't it?
Yeah.
Now we're going to do the other one. It's only to prove to you. 1, 2, 3, 4. 1, 0, 0, 1. 1 times 1, 1. 2 times 0, 0. 1 times 0, 0. 2 times 1, 2. Next one, 3 times 1, 3. 4 times 0, 0. And the last one, 3 times 0 and 4 times 1, which equals 1, 2, 3, 4, which equals A. Okay, so therefore, I times A equals A, I, which equals A. We have proven it. Okay? Any questions there?
No.
All right, have you got all that down? Because I'll clear it.
Yeah, I got it.
Okay, question 2. Question 2 says the matrix has an inverse. So it tells us, it gives us the inverse. We don't need to work it out. It just wants us to show that that's what happens. Okay, so let's start off. Left-hand side equals A times its inverse. Matrix A, 2, 3, 3, 5. Its inverse is 5, negative 3, negative 3, 2. Times them together. Okay, 5 times 2, 10, plus 3 times negative 3 is negative 9, so I'll write it as minus 9. 2 times negative 3, negative 6, plus 3 times 2, 6. Okay, next one, 3 times 5, 15. 5 times negative 3, negative 15. And the last one, 3 times negative 3, negative 9. 5 times 2, 10. When we work that out, we get 1, 0, 0, 1, which equals I as required. Okay, so we've proven that the matrix and its inverse, when we times them together, is just going to give us this identity matrix. Any questions there? Okay, I'll clear this one. All right, question 3. Find the determinant. So only doing the determinant, that's all we're doing. Okay, so here, the determinant of A equals, all right, 2 times 3, 6, minus 4 times 5, 4 5s are 20. 6 minus 20, negative 14. There we go. We can work out the inverse because we've got a number, not 0. Okay, let's work out part B. Determinant of matrix B. 4 times 3, 12, minus 2 times 1, 2, 12 minus 2, 10. Beautiful. We can work the inverse out of this one if we wanted to. And the determinant of matrix C. 2 times 2, 4, minus the 4 times the 1, the 4, 4 minus 4, 0. We cannot work out this inverse if they asked us. Any questions there?
No.
Okay. I can clear this one.
Yeah.
Question 4. Question 4 says find the inverse. Okay, so the first thing we're going to do is actually work out the determinant because in the inverse we need to find that out. Remember, when you do it on calculator, you can do all this anyway. So this one's going to be -6 minus -4, which becomes a positive, so we have -2. Okay, so now we're going to find the inverse of A, which is 1 divided by that number that we just found. Okay, swap the 2 and the -3. So the 2 comes up the top, the -3 comes down the bottom. The other two would change the sign. So -1 becomes +1, and +4 becomes -4. And there's our inverse. I mean, we can multiply the -1/2 in, but what for? Just leave it. That's all they wanted to find. Any questions on that one?
No.
Okay, let's do part B. The determinant of B. 2 times 3, 6 minus 6 times 1, 6, 6 minus 6, 0. Inverse of B does not exist. We cannot find it because it equals 0. Since determinant of B equals 0. Any questions on that one?
No.
Okay, I can clear this.
Yeah.
All right, now to do it on your calculator, I want you to get out your calculator. A 2 by 2 is exactly the same, 3 by 3 is exactly the same, okay? You don't need to do as it's showing here by storing it. You can just type into your calculator DET. It's in the catalogue, but you can just go DET and it's got open up your bracket, and then you can go and type in 1, 2, 3. So put in the matrix at 4, 1, 0, 2, 0, 2 and press enter, and it will give you the determinant of -20. Okay, you can store it like the calculator does, but try it. Okay, see if it works for you. And to do the inverse is even easier.
All right. Wait, what am I typing in again? The
Go in your calculator page. So open up your calculator page.
Yeah.
Okay, go and put in. Just start typing in DET and open up your brackets. The calculator would recognise that you're finding the determinant.
Yeah.
Okay, now go to your, where your catalogue is, where you put the 3 by 3 matrix in.
Yep.
Okay, start filling it in. 1 tab, 2 tab, 3 tab, all the way until you get to the end.
Yep, I did that.
Make sure you close your bracket. I think it might work even without closing the bracket, and press enter, and you should get -20.
Yep.
Okay, got it?
Yep.
Okay, now, see, they stored it here. You don't have to store it. You can just do it like this. If it's a one thing, don't bother storing it because you've got to type it, store it, just type it straight away, right? Now, this is the way we're going to do the inverse. Because you've already typed it, go up and press enter on this line, the determinant line.
Yep.
Okay, remove all this. Remove that, so you only have the matrix there. This is the easiest way for you because, again, we can store it, but there's no point. Okay, and then once you've removed it all, put in your little witch's hat, press your little witch's hat, it'll give you the little box up here, and type in the negative, not the minus sign, the negative, the one with the brackets, and 1, and press enter.
Wait, -1 or one? Wait, which one?
The one with the brackets around it, not the minus sign, the one with the brackets, right?
Yeah.
And press enter, and you will get the answer. That's the inverse of the matrix.
Yeah, I got that.
Okay, that's the easiest way to do it when it's only a one-off. All right, that's it. That's 12A.
Oh, okay.
All right.
Okay, thank you.